All right, let's talk about when graphs are not discrete, but they're continuous. As you look at all of these examples on this page, they're all continuous. And the reason why I would consider them continuous is that while some of the points are marked, there's an infinite number of points on all of these lines. I cannot count that. That means I would have to measure how many points there were, and if it's measurable, then it's continuous. So let's go ahead and answer again if these are functions. And I'm going to go ahead and let's just do all of the functions questions at once. Is this one a function? If I drew a vertical line, it's going to cross 2 times. So no, it fails the vertical line test. If I look at this example, I draw my vertical lines that is only ever going to cross that W 1 time. So yes, it passes the vertical line test. This next example, same thing. If I draw vertical lines, it's only going to cross once. So yes, it passes the vertical line test. This next example, if I draw a vertical line right here, it's going to cross 2 times. So no, it's not a function. It fails the vertical line test. This one, does it pass? Draw some vertical lines. It only crosses my diagonal line 1 time in each spot. So the answer is yes. For the same reason, it passes the vertical line test. And if I look at this last one, draw a vertical line, it looks like there was a second that I was going to cross more than one, but the answer is yes, it still passes the vertical line test. All right, now that we have that underway, let's talk about the domain and range of these. Now, when we did our activity the other day in class, remember that our domain and range, they're like boundaries, the lower boundary to the upper boundary. Now let's talk about what that looks like. Remember, my domain is all of the possible values of x. Now, sometimes I've seen people, they are like, oh, that x value is 2, that x value is 5, that x value is 7, done. Well, remember, there's those infinite number of points in between that I need to list. So I need to list 2.5, 2.25, and it's going to be impossible for me to list them all. So instead, I'm going to list using intervals. I'm going to say my x values start here and end here. Let's draw in those boundaries. I'm going to make sure I cover my entire graph. So domain, remember, is side to side, and range is the up and the down. So if I draw my boundaries, I would have one boundary line here and one boundary line here. Okay, in between those 2 boundary lines, I have covered my entire graph. So those 2 boundaries are going to represent my domain. So let's list our interval. Remember, to write an interval, I'm going to write an x in the middle, and I'm going to say my lower boundary is at 1, 2 on the x. 1, 2 on the x. And the upper boundary is at 1, 2, 3, 4, 5, 6, 7. So I'm going to write this as an interval, saying 2 is the smallest thing, notice the alligator mouth, it can equal, and 7 is the greatest thing. And I'm done with my domain. Let's talk about range. Range is how far it goes up and down. Well, if I wanted to cover the entirety of my graph, but not too much, I would draw a line here that covers all of the bottom of my triangle, and I would draw a line here covering all the way to the top of my triangle. So notice in between those green lines, I have encompassed my whole triangle. Range stands for y, so I would put y here in the center. My smallest y value, make sure you're doing bottom to the top. So the bottom value, make sure you look and see where it crosses the y-axis. So 1's the bottom value, and 1, 2, 3, 4, 5, 6 is the top value. To write my inequalities in here, 1 is the smallest thing, alligator mouth, smallest ends to 1. Alligator mouth should be eating 6 because that's the largest. All right, take a second and try the next one on your own. All right, let's go ahead and do this together. So my domain, side to side. So from here all the way to here. So x is in the middle. My smallest value is negative 1, 2, 3, 4, 5, 6. So negative 6 is the smallest. 1, 2, 3, 4, 5, positive 6 is the largest. Make sure the alligator mouth is not eating the negative 6 and it's eating the positive 6. My range, y. Now notice, because my smallest number is always over here, I'm always going to have my small side facing that direction. Now, to cover my entire graph. Now, please be careful when you're drawing in your boundaries. Sometimes I've had people draw lines in right here as my top boundary, right here as my bottom boundary. That doesn't cover all my graph. I need to slide those boundary lines, one to right here, to make sure I cover everything to the bottom of my picture, and here to everything to the top of my picture. Let's go ahead and write those numbers in. So my bottom boundary here is here at 0, and my top boundary is at 1, 2, 3, 4, 5, 6. Again, it's not eating the 0 because it's the smallest, but eating the 6 because it's the largest. Now up until this point, I've been using or equal to signs on each of these problems. And that's because there's been filled in dots at all of those places. But when I do problems that have open circles, like this next one, I have to consider that something is not equal to. So let's go ahead and do this example together. So if I'm covering from side to side, there's my boundaries. X goes in the middle. Smallest number is 1, 2, 3, 4, negative 4. Now there's an open circle, so I'm not going to put an or equal to sign underneath. My largest value is 1, 2, 3, 4, 5, and I'm not going to put a line underneath because there is an open circle. Let's talk about our range. Our lowest value is not here, our lowest value is here. So make sure you draw a line underneath that lowest value and a line above the highest value. I've encircled my whole graph with my boundaries, which is what I want to do. My lower boundary is down, so make sure you do the bottom to the top. So down at negative 2, and my upper boundary is up at 1, 2, 3, 4, 5. Now, here's the tricky part. I don't see anything right here. I don't see a closed dot or an open dot. If there's nothing, we're going to assume that there's a filled in dot right here. So less than or equal to negative 2. And since there is an open dot right here on this boundary, open. All right. So we've talked a lot about domain and range of these type of graphs. I want to introduce you to problems that have arrows. Okay? When something has arrows, that means that it's going to continue in that direction. So for example, if I'm listing my domain, I have a boundary line right here. That's as far left as my graph goes. And if I were to draw my boundary line in over here, okay, that's an okay temporary boundary, but these arrows are going to continue to push that boundary line. So it would move to here. And then as it kept going, it's going to push it to here. So there is no boundary line over here. There's no boundary on the right. So when I list my domain, I'm still going to write X. I'm still going to write my smallest boundary, which is 0. But I'm going to leave off the upper boundary because there is none. So what does that look like? 0 is the smallest thing, so small side facing to 0. There's no open circle, so or equal to. Let's talk about the range. If I'm talking about the range, then I'm going to draw a temporary boundary right here. But as this arrow keeps going, it's also continuing down. And my temporary boundary keeps getting pushed further and further down. And the same thing happens on the top of this line. This keeps going up, and my temporary boundary keeps being pushed upwards. So what does that mean? That means I have no boundary lines. That means my y value can be anything. So what I'm going to write for my range is all real numbers. every single number can be a range value. And remember that the fancy symbol for that is that fancy R. Let's look at another example. Domain. So I go to draw in my boundary lines. Oh, that's not a boundary because there's an arrow continuing that direction. I go to draw in my boundary there. Oh, there's an arrow pointing in that direction. So I have no boundaries for my domain. So remember, when you have no boundaries, the answer is all real numbers. So let's try the range. I go to draw my bottom boundary. The arrow keeps pushing it this way. I go to draw my top boundary. The arrow keeps pushing that boundary upwards. And again, okay, if it keeps going, there's no boundaries. All real numbers. Let's look at this last example. I go to write in my domain boundary, but the arrow keeps pushing it this way. Same thing on this side. So again, all real numbers. But what about my range? Is my range all real numbers? Well, let's draw it in. So I'm going to draw my bottom boundary first. Hey, there's no arrow here. That means I do have one boundary. My bottom boundary is 0. I'm going to write y because I'm looking at the y values. And what is my top boundary? Well, again, those arrows are going to continue to push my line up. So there is no top boundary. I'm going to leave over here blank. 0 is the smallest, so I'm going to make sure my alligator mouth does not eat the 0. And there's no open circle right here, so I'm going to put an or equal to. And that is how I find domain and range from continuous graphs.